Hello, good morning, students.
Good
Good morning, Ganga. వినిపిస్తుందమ్మా?
Good morning.
Good morning. Okay.
వీడియో విజిబుల్ లేదు మేడం.
షేర్ అవ్వట్లేదా స్క్రీన్?
అవుతుంది మేడం ఇప్పుడు.
అవుతుందా? Okay. Today we are going to discuss some questions came in previous exams from trees and the data structures. Okay, trees and linked list and graphs concept. Now we are going to discuss about those questions. These all are came in previous competitive exams. First, see what does the following functions do for given linked list with the first node as head. So this is a function. So after executing this function, so what is the output? So now listen here. This is a function. Here we are pass some head node. That is head is the sense of that is the first node. Here head equal to null means return. That means empty list is returns. So otherwise move to head to next. That means this function is a recursive function. So every time it displays what? Header data. Means what is the output of this one? Prints all the nodes of the linked list, prints all the nodes of linked list in reverse order, and so prints the nodes of linked list, prints the alternative nodes in reverse order. Okay, so first you can observe here in this case first head dot next. For example, if our linked list contains 1 2 3 4 5 elements, so for the first time uh, our function is executed, and for the first time first node is treated as a head node. So first node is treated as a head node. Okay, now this first node you can add. That means for the first time head dot next. That means this is the first node. Now next time first dot head. So after that again it moves the first dot head, and after that it moves the first dot head, and that is the next dot head like that here. So return how this is returns. That means once this is a recursive function, after completion of all this it returns some head value, means header data. So first all these values are stored in, that means function, while executing the function here it uses the stack data structure, so that it stores in the stacks. So that means here head dot next, in the sense first it returns initially this is the first one, and that is nothing but head. After that this is the head dot next, again the function is called this is the head dot next, and next one this is the head dot next. After that this 5 is the head dot next. So that while returning that function it returns what? Head dot data for the first 10. That means 5 is the first 10, next 4, next 3, next 2, next 1. That means this code returns or prints all the nodes of a linked list in reverse order. And coming to the second question, which of the following points about linked list data structure, that means compared with array. So that means compared with array, which of the following points are true about linked list? Arrays have better cache locality that can make them better in terms of performance. First option. Second option is it is easy to insert and delete the elements in a linked list. Okay, random access is not allowed in typical implementations of linked list. The size of the array has been pre-decided, so linked list can change their size in any time. That means coming to this first point, arrays have better cache locality. So that using that cache locality, so we can make them better in terms of performance. Means so using the cache locality in the sense using the index. So that means whenever you require any particular element, you can retrieve that particular element very fastly. So that performance is improves. So that cache locality is better. Because of that reason, performance is increased. And coming to the other option, it is easy to insert and delete the elements in linked list. That means we can easily insert elements into the linked list as well as delete the elements from the linked list, because wherever you want you can insert, just you can change that address pointer. And coming to the random access is not allowed in a typical implementation of linked list. Suppose whenever you can search any particular element, compulsory you can start from first itself. And the size of the array has to be pre-decided. That means linked list can change their size any time. That means the size of the array has to be pre-decided. That means in array there is a static allocation, so that the while you are declared the size before you know the how many number of elements are stored in that array. That means what is the size of array is decided uh, before using that array, so that the array size has to be pre-decided. So whereas coming to the linked list can change their size in any time. That means all these points are true. That's why the answer is what? E. And coming to here, both arrays and linked list can be used to store the linear data items. So they have some advantages as well as disadvantages. Coming to the advantages as well as disadvantages. So before discussing that, here this is what the representation of this is array representation and this is a linked list representation. We know that very well. And coming to the differences between these arrays and linked lists, whereas coming to the array is the data structure that contains a collection of similar elements, whereas the linked list considered as a non-primitive data structure, it contains unordered linked list elements. That means there is no order, sequential order. These elements are stored in random locations. In the array, elements belongs to indexes, whereas in suppose you can retrieve some fourth element, directly you can move to that fourth index and just you can go through that one. Whereas in the linked list, so this is not possible. Suppose you can retrieve the fourth element, you can move from the you can start from the starting element. So accessing an element in array very fast, we know that, while the linked list takes some time. The operations like linked list and deletions in array consumes a lot of time, because of in the insertions and deletions, array can move backward and forward. All the indexes can change it. So whereas in linked list this is done very fastly, because only one size is specified. And coming to here, now coming to in an array, memory is assigned during compile time, while in linked list it is allocated during execution time. That means array size మనకి ముందే తెలియాల్సిన అవసరం అనేది లింక్ లిస్ట్లో సైజ్ ముందే తెలియాల్సిన అవసరం అనేది లేదు. అండ్ కమింగ్ టు హియర్, and here the elements are stored consequently in arrays, whereas in randomly elements are stored in linked list, so that retrieving is very late in linked list, so sequential locations is fastly. Okay, so in addition, the requirement of memory is less due to actual data being stored within index in an array. There is that means in the linked list, due to storage of additional next element, so memory size is very large. That means array lo, that means only index tone direct ga we can access kabatti storage time lo, that means less storage, whereas here in the linked list for every node we store the address as well as the data. That means more. So in addition of this, the size of the array is fixed, so that we know the upper limit. That means compulsory how many number of elements are stored inside, that is known earlier. And coming to the linked list concept, that is not possible. Okay, you can insert any element from 1050. After that you can move all these two elements. You can delete any element 10, this is, and that means 1050, 2000 and 2040, all these are moved backward. The next, deletion is also expensive with arrays until and unless some special techniques. That means manaki deletion is very takes lot of time. So whereas in linked list, these are the dynamic size and easy of insertion. Okay, because wherever you want you can insert those elements. So this is already we are discussed in the previous classes. Now we can move to another question. So here in this following function, it takes a reference to head of the double linked list as a parameter. So this is a double linked list as a parameter. Assume that a node of double linked list has previous pointer as previous and next pointer as next. And you can assume this one function. What is the output? Assume that the reference of head of the following double linked list is passed the above function 1 2 3 4 5 6. So what should be the modified list after the function call? So initial linked list is like this. This is a double linked list. Initially the double linked list is like this. After modifying this one, what is the output? That means here some temporary node is there. Initially some current node is created. So that current node is nothing but first node is assigned into this current node. Current not equal to null means, so temp equal to current dot previous. Okay, so current dot previous. Here what is the head of the double linked list as parameter, that it takes a reference to head of the double linked list as parameter. So in this case you can assume this head as a what? Last node. So okay, head is nothing but last node, and here temp equal to current dot previous. So current dot previous is stored into this temp, and current dot previous equal to current dot next. Now current dot next value is stored into current dot previous. Now current dot next equal to temp. Now current equal to current dot previous. Okay, సో ఈ ఎగ్జిక్యూట్ అయిపోయిన తర్వాత దెన్ వాట్ ఈస్ ద అవుట్పుట్ అని ఇక్కడ అడుగుతున్నారు. దట్ ఈస్ ద గివెన్ ఫంక్షన్ reverses the given double linked list. That means option is C. So first it moves to here. That means current not equal to null ayenta variki this is repeated. So every time the previous is stores into previous loki next వస్తుంది. సో నెక్స్ట్లోకి ప్రీవియస్ని స్టోర్ చేస్తున్నారు. అంటే కంటిన్యూస్గా ఏమవుతుంది, సపోజ్ 1 2 3 4 5 6 ఉంది. సో ఫర్ ద ఫస్ట్ టైం this is what, suppose you can assume this is the current. Okay, then next this is the current dot previous, this is the temp. Now this is the next, this is the current. Okay, this current dot next equal to enti this temp value. Okay, next current equal to this is the previous, అంటే now this is the previous. సో ఇలా మనకి మూవ్ అయిన తర్వాత హెడ్ లొకేషన్ ఏముంటుంది, దిస్ ఈజ్ ద హెడ్ 1. సో వన్స్ ఇట్ ఈస్ హెడ్, ఆటోమేటికల్గా మనం డిస్ప్లే చేయడానికి ట్రై చేసామనుకోండి, సో ఇట్ కెన్ డిస్ప్లేస్ ఫ్రమ్ రివర్స్ ఆర్డర్. సో కావాలంటే ఒకసారి మీరు ఫిగర్ వేసేసి చూడండి. 1 2 3 4 5 6 ఉన్నాయి. సో నౌ ఇక్కడ టెంప్లోకి ప్రీవియస్ వాల్యూ స్టోర్ చేస్తున్నారు. నౌ ఇది టెంప్, దిస్ ఈజ్ ద కరెంట్. నెక్స్ట్ టైం దిస్ ఈజ్ ద టెంప్, దిస్ ఈజ్ ద కరెంట్. నెక్స్ట్ టైం దిస్ ఈజ్ ద టెంప్, దిస్ ఈజ్ ద కరెంట్. నెక్స్ట్ టైం దిస్ ఈజ్ ద టెంప్, దిస్ ఈజ్ ద కరెంట్. నెక్స్ట్ టైం దిస్ ఈజ్ ద టెంప్, దిస్ ఈజ్ ద కరెంట్. ఓకే, ఇక్కడ ఇది కరెంట్ వాల్యూ. నో డిస్ప్లే చేయడానికి ట్రై చేసామనుకోండి ఏమవుతుంది, సో రివర్స్ ఆర్డర్లో డిస్ప్లే అవుతుంది. నౌ what is the output of the following function for this node? So this is the code. So in the linked list 1 2 3 4 5 6 are there. So starting equal to null. So if there is no nodes, empty node, so now it is the empty, just display empty value. Okay, after that if it is not empty, now start, అంటే if it is empty it returns. empty కాదు అనుకోండి, first node is displayed, then next start dot next not equal to null. Okay, after that start dot next means start dot next dot next అంటే not equal to null. So next move to next one. Okay, after that and after that display this data. Okay, so in this function 1 3 5 5 3 1, so it displays 1 3 5 5 3 1. So now see here what, so first it displays here 1 start dot data 1, and after that start dot next not equal to null. Yes, it is not equal to null, it contains something. Okay, this is the starting value. First it displays start dot next not equal to null, it contains something. So ఇక్కడ function returns, that is start moves to here. Yes, Okay, this is the recursive function. Now coming to here, start not equal to null. It contains the address of this one. Okay, now enter into here, that is next statement is start dot data, that is now 3. 3 is displayed, 3 is 3 is displayed here. And after that, this is also not equal to null. After the start dot next not equal to null. Okay, next here our element is start dot next not equal to null. Yes, it is not equal to null. Now move to here, that is start dot data. Sorry, before that first it displays what any, coming to here, that is start dot next not equal to null. Yes, again not equal to null, isn't it? That means one, now it represents what, this is the start dot next, current start value. Now start dot next not equal to null. Yes, now start dot next, that means it now points to this one. So now again the node here, this is also not equal to null, so that enter into here as. So now it displays what, this value. After that start dot next not equal to null. S, start dot next not equal to null, and start dot next equal to null. S. Now it is stores the start value, stores what, any null value, so that it returns. So after returning here, the printf is there. That means in the stack, how many elements are there? 1, 3, 5 are there. So those 3 elements are stored in the stack, so that those are displayed in the reverse order, that is 5, 3, 1. Now the output is this one. That means this function prints alternative nodes of a given linked list from head to end, and after that, and then from end to head. If linked list has even number of nodes, then it skips the last node. Okay. So this is what that means, because this is 3 are displayed in the function itself, and these 3 are displayed while executing the function. These 3 are stored 1, 3, 5. So after closing the function, it returns in the term from top, so that 5, 3, 1. Now sixth question, the following C function takes a simple linked list as an argument. Okay, it modifies the list by moving the last element to the front of the list. Last element is front of the list, and returns the modified list. Okay, now what is the code? And this the purpose of this code is, the following C function takes a simple linked list as an input argument. So here simple linked list as an input argument. It modifies the list by moving the last element to the front of the list. It modifies the list by moving the last element to the front of the list, and returns the modified list. That means last element becomes the first element. So now some part of the code is given here, some part is left over. Now you can choose that part, leftover part. So here first node head not equal to null, head dot next not equal to, either 2 points, head not equal to null or head equal to null. So in this case, suppose you can observe. So this is what the explanation here. Now see here, suppose whenever node is moved, first head not equal to null, head equal to null or head not next equal to null, any one of the condition, return head. Okay, head equal to null means empty, head not equal to null means first node. Okay, now after that, if it is not, something is there, you can observe here some 3 nodes are there, q equal to null and p equal to head, and initial ka p equal to null and p equal to head first node, and q equal to null empty node. Now p dot next not equal to null. Yes, here 3 nodes are there. So first node is assigned into here, and next it moves to here. So after that, return head. So now you can make this last, after completion of this one, you can make it as p, you can make this p as q. That means after completion of this one, uh, here in the after closing this while loop, you can make this p equal to q. Okay, now here you can observe here, now the head node is nothing but p, head node is nothing but p. So option D is the right answer. Head node is a p, that means first node. And next you can make it q dot next, and before this, every time that means q equal to p, p equal to p dot next. After this code, you can write down p equal to head equal to p. That means head is in the sense first node. Now head equal to p, and after before that you can assign here q dot next equal to null, means last node. Lastly, that means after completion of this one, you can write this one p dot head equal to next. అంటే ఫస్ట్ యూ కెన్ రైట్ హియర్ క్యూ డాట్ అంటే ఇన్ లాస్ట్ వన్ పీలో ఏముంటుంది మనకి పీ డాట్ నెక్స్ట్ కంటైన్స్ ద నల్ వాల్యూ ఇజెంట్ ఇట్. దెన్ నెక్స్ట్ క్యూ ఈక్వల్ టు పీ లాస్ట్ నోడ్ ఉంటుంది. నా యూ కెన్ మేక్ ఇట్ యాజ్ క్యూ డాట్ నెక్స్ట్ ఈక్వల్ టు నల్, క్యూ డాట్ నెక్స్ట్ ఈక్వల్ టు నల్ అండ్ head equal to p, and next p dot next equal to head, because we can in the previous case, that means suppose you can observe here like this. uh, suppose this is the node like this. Okay, now here this is the node, and now this is the another node like this, and now this is the another node like this. Okay, now this is the initially head node, this is head node. So now I can make this node as p, and after that I can assign this p into q. Then next after that, so I can assign this q p into this q. Next this is now p. Okay, then now in the next case this is the q, now this is the p. Okay, and after that this is the last node, so that you can make this node as head node. This node has head node, and you can make this as q dot next equal to null. So you can make this q dot next equal to, assign q dot next equal to null value, q dot next equal to null, means this is now the last node. Now you can make it as a, this is the what, first node, so that p equal to what, here you can assign what, h, p equal to h. So now this p, now you can add to here, so that p dot next, p dot next equal to what, head. So in the previous case, what is this, this is the head itself. So this is the head node, so that you can connect this node to here and make it, this is a null node. So this is what, null. Now you can make this as a last node, and this is the front node, you can take here, and so that you can make this as a first node, and after that no, p dot next equal to head node. So this is what the concept, how we can assign that node. Okay, so this is what the code here. Now see here, that is the code here, so that q dot next equal to null, okay, and p dot next equal to head, and now you can make it as a head is equal to p. So this is what the code. So now this is when the while loop ends. So p contains address of the second last, that means second last, and p contains address of the last node. So we need to following things, that is, first you can make this q dot next equal to null, and after that p dot next equal to head. So you can break here, that means here the break is there, that means q dot next equal to null, so some break is there, and after that p dot next equal to what, here, head. So that now this last node is represents the head node, first node. Now you can make this first p as a first node. Okay, so that these three the complete of the code after completion of this while loop. Okay, this is what the concept. And next question, the following C program takes a single linked list of integers as a parameter and it rearranges the elements of the list. The function is called with the list containing the 1, 2, 3, 4, 5, 6, 7 in the given order. What will be the contents of the list after the function completes? Okay, here this is a function list not equal to null and list not next equal to null. That means here some nodes are there. So that initially p equal to this one and q equal to this one. Now temp equal to p dot value and value equal to this one and value equal to temp value. Then next 10. So if it is p, now ternary operator, now this is p dot next, otherwise 0. So null kakapothe it can move to here. Now what is the output of this one? That means, so it the function rearrange the elements, that means exchange these elements. So here swapping function is there. You can observe here temp equal to some element and p equal to this q element, q equal to this temp element. So here swapping is there. After swapping next element ki move avutunnamu. So this is a continuous process. That means our program is what here. So our list contains these elements. So first these two elements are swapped and after that it can move to here. Okay, now these two elements are swapped here. After that moves to here, these two elements are swapped here. So then next there is no elements after that. Last element is not there. Only odd number of elements are there. That's why. So here it can check. So only one element is there. P dot next equal to null. So it returns. Otherwise one more time. That means q equal to q dot next. Okay. And q equal to p s. Something is there. If it is something is there, next it move to the next node. So if it is not there, 0 means null value. That's why here it is close until the q not equal to null. So q value null 0 ayenta varaku it can repeat. So that in this program the function rearrange function exchange the data of every node with its next node. It starts exchanging the data from first node itself. Okay, so next we are discussed some of the questions regarding trees concept. So which of the following is true about binary trees? Every binary tree is either complete or full. Okay, every complete binary tree is also full binary tree. Every full binary tree is also complete binary tree. So no binary tree is both complete and full. So now see the explanation here. Every binary tree is either complete or full. No. So sometimes that binary tree is a strictly binary tree also. Okay. Every binary tree, every time మనకి complete binary tree అవ్వాల్సిన అవసరం లేదు or full binary tree అవ్వాల్సిన అవసరం కూడా లేదు. So for example, suppose see here, in this case, go to here. Suppose you can observe here, every binary tree. So now you can observe here. Observe here, this is a node. Okay. Now, so this is a root node and this is the left child. Now this is the tree. And now you can observe this is a complete binary tree. Suppose you can observe here, this is another node is there. Now you can treat it as this is a full binary tree. Suppose you can take this is neither complete binary tree nor full. Suppose you can observe here in the complete binary tree, here how many number of nodes are there? 4 nodes are there. So that how many number, that means while you are assigning the numbers, numbers to here, so that numbers, that means the root node number is 1, this is 2, this is 3, whereas here the 4 and 5, these two are skipped and this is a 6. So that 1, 2, 3, 6 is there. So continuous, that means that in the complete binary tree, compulsory ascending order, each and every node numbering is in ascending order from 1 to n compulsory, whereas here ascending order is there, but those are 1, 2, 3 and 6. So that this is not a complete binary tree. Whereas coming to the full binary tree, suppose you can observe here, this is not a full binary tree, because in the full binary tree, so all levels, that means the last level must be contains full with all the leaves, but here this is empty and this is also empty, so that this is not a full binary tree. That means first point is not. And coming to the strictly, suppose you can observe here, this is the strictly binary tree. Suppose you can observe, this is a strictly binary tree, even though this is not a complete binary tree as well as full binary tree. Okay, now move to here. Every binary tree is either complete or full. So this is the false statement. Every complete binary tree is also a full binary tree. Not, because in the complete binary tree, so the last level may or may not be filled with all the leaves, whereas in full binary tree, last level must be filled with all the leaves. And every full binary tree is also a complete binary. That means every full binary tree is a complete binary tree, but every complete binary tree is not a full binary tree. So that these two statements also false. And coming to the no binary tree is both complete or full. So no binary tree is complete the full binary tree as well as no complete binary tree. So that none of this from these four statement, no state that means any statement is not true. So that none of the above. Next, coming to the 10th question. A complete binary tree is a binary tree in which every level except the possible the last is completely filled. So in complete binary tree nothing, but it is a complete binary tree is nothing but a binary tree in which every level except the last level is not completely filled. The nodes are as far left as possible. From left to right only elements are stored. Okay. So from this A, B, C, D options, which one is correct? So is incorrect. For example, the following binary tree is neither complete nor full. So first statement, example for this A, every complete binary tree. So as already I am given, this is the complete binary. This is not a complete binary tree, because in this next level, here one children is there, but this children is not present here, so that this is not a complete binary tree. And coming to in the B, here this is a this is also incorrect. The following binary tree is complete but not full, because here if you left right children and here left right children and left children, then only these are full. And coming to this is also incorrect. That means this following binary tree is full but not complete. Okay, here the leaves are, that means leaves are there, but this is not full. And this following binary tree is complete but not full. So that this is also that means all the statements are false. And next question, if arity of operations is fixed, okay, in then which of the following notations can be used to pass the expressions without parenthesis? Okay, infix notation, in order traversal of expression. Postfix is nothing but postfix traversal of expression. Prefix nothing but prefix traversal of a expression. So ikkada figure miss ayindandi, leave it this question. Miss ayindi. Next we can discuss that next question. What are the main applications of tree data structures? It manipulates the hierarchical data, make information easy to search, and manipulate the sorted list of data, and router algorithms, form a multi-stage decision making like chess game. So as a workflow for compositing digital images for visual effects. These all are the applications for this tree. Anni kuda applications. Hierarchical data means manaki data vachesi we can add in hierarchical manner. That means directory is there, in that number of subdirectories are there. In that way, hierarchical manner we can assign the data, and information is, that means easily we can search. Suppose coming to the binary search tree concept. So we can easily search the element. Okay. And storage is also very manipulate the sorted list of data very easily. And router algorithms, that means suppose the source to destination you can find out the minimum distance, router algorithms are very much useful. Form a multi-stage decision making. Suppose some multiple decisions are there, you can go to first if condition. If it is the condition false, goes to next if statement. In that also condition false, no, go to other next if condition. In that case, suppose the condition is true, go to true part. And next question, level of a node is distance from the root to the node. Okay, for example, level of root is 1 and the level of left and right children roots is 2. The maximum number of nodes on a level I, how many number of maximum nodes are there? That means how many number of nodes are there? First root level is 1. Root level is 1. Here we are observing the root level is not 0. Here the root level is 1. Okay. Root level is 1. In that case, what is that? Root level is 1 means, or at that root how many number of nodes are there? That is 2 to the power of 1 minus 1, isn't it? 2 to the power of 1 means 1. 2 to the power of 1 means 2. 2 minus 1 means how many number of possible nodes are there? Only 1. Whereas in next level, how many number of possible nodes in the tree if the level is 2? If the root level is 1. Here we are observing the root level is 1, not the 0. If it is 0, 2 to the power of 0 equal to 1. But here 2 to the power of 1 nothing, but automatically the formula becomes changed. That is 2 to the power of h minus 1. So r to the power of I nothing but here level 2 to the power of I minus 1. Here I value now 1. 2 to the power of I means what only? 2. 2 minus 1 means 1. Total how many number of nodes are there at level 1? Only 1, one node. Whereas coming to the level 2, that means 2 to the power of 2 means 4. 4 minus 1, 3. That is what is the formula? 2 to the power of I minus 1. This is the formula. 2 to the power of I minus 1. Here I indicates what? 2 to the power of I minus 1 is the formula. So see here, this is the formula. 2 to the power of I minus 1. That means 2 to the power of 1 minus 1, 0. 2 to the power of 2 minus 1. There is, and at the level, the maximum number of nodes on level is nothing but 2 to the power of I minus 1. అదే సపోజ్ లెవెల్ కనుక 1 అని అన్నాము, అప్పుడు వాట్ ఆర్ ద మ్యాక్సిమం నెంబర్ ఆఫ్ నోట్స్, హౌ మెనీ నెంబర్ ఆఫ్ మ్యాక్సిమం నెంబర్ ఆఫ్ నోట్స్ ఇన్ ద ట్రీ అంటే అప్పుడేం చెప్తాము? 2 to the power of I minus 1 అంటాం, isn't it? Okay, 2 to the power of I minus 1 is different, 2 to the power of I minus 1 is different. సో విత్ ఇన్ ద బ్రాకెట్స్లో ఇచ్చాము అంటే ఏంది? 2 to the power of I minus 1. 1 minus 1, 0 means 2 to the power of 0, 1. సో లెవెల్ కనుక 2 అయితే 2 to the power of 2 minus 1. That means 2 minus 1 nothing but 1 means 2. 2 to the power of 1 means 2. ఓకే, అదే హౌ మెనీ నెంబర్ ఆఫ్ నోట్స్ అన్నాం అనుకోండి, అప్పుడేమంటాం 2 to the power of I ఆఫ్టర్ దట్ minus 1. నోట్ ద పారంథసిస్లో ఇవ్వకుండా 2 to the power of I ఇచ్చేసి తర్వాత -1 అంటాం, అప్పుడు టోటల్ నెంబర్ ఆఫ్ నోట్స్ వస్తాయి. ఓకే, సపోజ్ లెవెల్ 2నే ఉంది, హౌ మెనీ నెంబర్ ఆఫ్ పాసిబుల్ నోట్స్ ఇఫ్ ద రూట్ లెవెల్ ఈజ్ 1 అన్నారనుకోండి, అప్పుడేంటి లెవెల్ ఇక్కడ మనకి ఎంత? 2 లెవెల్స్ అన్నాము. దట్ మీన్స్ 2 to the power of 2 means 4 minus 1. టోటల్ పాసిబుల్ నోట్స్ వచ్చేసి 3 అవుతాయి. అదే లెవెల్లో చెప్పమన్నారనుకోండి 2 to the power of I minus 1 means 2 minus 1. Okay, next question, the maximum number of binary trees that can be formed with the unlabeled nodes is? Okay, the maximum number of binary trees that can be possible with unlabeled nodes is, suppose here these all are the possible trees. Okay, suppose here unlabeled only 3, ఇక్కడ 3 అని ఇవ్వాలండి. The maximum number of binary nodes can be formed with 3 unlabeled nodes. 3 unlabeled nodes, isn't it? Here 3 missed. Sorry, 3 is there with 3 unlabeled nodes. Now this is one node, this is one tree. Next possibility is this is, next possibility is this, next possibility is all right, next possibility is right, left. Okay, so suppose here 3 nodes are given, this is very easily we can find out. Whereas more than 3, this becomes very typical to find out how many number of binary trees with the given n number of nodes. If it is 3 only, we can find very easily. Okay, how it is possible? So that is find out by using Catalan number. Catalan number is nothing but this is the Catalan number. That means here 2n divided by n plus 1. This is what the Catalan number. That means note that nodes are unlabeled. So if the nodes are labeled, we get more number of trees. Here these are the unlabeled కాబట్టి అంటే లేబుల్ ఏబిసి ఇచ్చామనుకోండి, ఏని ఇక్కడ కూడా ప్లేస్ చేయొచ్చు, ఏని ఇక్కడ ప్లేస్ చేయొచ్చు, ఏని ఇక్కడ ప్లేస్ చేయొచ్చు. అలా we got the more number of trees whenever nodes are labeled. So here nodes are unlabeled, that means you can treat it as a only one, whereas this is a labeled one, either this is a or B or C. Okay, in that case possibility of binary trees are more, whereas unlabeled nodes, the possibility of binary trees are very less. Okay, so this is the concept. Node here the height of the binary tree is, this is what the binary tree, this is what the here n equal to 3. Now the number of binary trees here, this is what the Catalan number, that is 2n combinations, 2n combinations n divided by n plus 1. That means here 2 into n means 3, 3cn divided by 3 plus 1. This is what 6c3, 6c3 divided by 5. What is the 6c3 value? N factorial divided by p factorial minus p factorial into n minus p factorial. Here n value is what? 6. Okay, that means NC3 formula, NCP formula ఏంటండి? n factorial divided by p factorial into n minus p factorial. n factorial nothing but 6 factorial divided by 3 factorial into 3 factorial. That means 6 into 4 into 5 into 4 factorial means what అండి? 6 into 5 into 4 factorial, 6 into 5 into 4 factorial into 3 factorial means 3 factorial in 3 factorial got, and 3. What is that? That is also cancelled. 3 into 3 factorial cancelled, and 3 into 2 6 cancelled. The next only there 5 into 4 is there, means 5 into 4 divided by 3 plus 1 means 4. 5 into 4 nothing but 20 divided by 4 nothing but what అండి? 5. So that is the formula. This is most important formula, the Catalan number. The height of the binary tree is the maximum number of edges in root to leaf path. The maximum number of nodes in a binary tree is height is what అండి? That is 2 to the power of h plus 1 minus 1. So ఒకవేళ the height of the binary tree is the maximum number of nodes from leaf to this, maximum number of edges present from leaf node to root, that is nothing but height. How we can find out the height? That is, if height equal to h, how many number of maximum nodes are there? 2 to the power of h plus 1 minus 1. Okay, here you can observe here height equal to 1, that means only one node is there. Height equal to 2, maximum nodes are 1 plus 2 3. So if it is height equal to 4, that is maximum number of nodes is 1 plus 2 plus 4, that is a 7. Okay, like that total number of nodes is 2 to the power of h plus 1 minus 1. And in the delete operation, that is binary search tree, we need in order successor or predecessor of a node. So when the node to be deleted has both left and right children as non-empty, which of the following statement is true? In order successor is always leaf node. In order successor means, so in order lo successor nothing but ఏంటండి? leaf node, left node means ఏంది? that is a successor. సో successor ఎప్పుడు కూడా ఏముంటుందండి? స్మాల్ ఉంటుంది. సో in order successor is always leaf node. S. In order successor, sorry, one more thing. In order successor is always either a leaf node or node with empty left child. Okay, suppose root node ఉంది, left right ఉన్నాయి. ఓకే, లెఫ్ట్ రైట్ ఉంటప్పుడు ఏంది? లెఫ్ట్ రైట్ కనుక మనకి లీఫ్ నోడ్స్ అనుకోండి, అప్పుడు ఇన్ ఆర్డర్లో కంపల్సరీ సక్సెసర్ ఏమవుతుందండి? లీఫ్ నోడ్ అవుతుంది. సో ఓకే, నెక్స్ట్ always either a leaf node or node with empty leaf left child. కంపల్సరీ ఏం కావాలి మళ్ళీ మనకి లెఫ్ట్ చైల్డ్ అనేది కావాలి. Okay, in order successor may be an ancestor of the node, not the ancestor. Compulsory there is a successor only. ఆ సక్సెసర్ కూడా కంపల్సరీ లాస్ట్ లెవెల్లో కంపల్సరీ మస్ట్ బి ఏ లెఫ్ట్ చైల్డ్, మస్ట్ బి ఏ లెఫ్ట్ చైల్డ్. నెక్స్ట్ 17th question. We are given a set of n distinct elements and all these are unlabeled binary tree. In how many ways can populate the tree with a given set so that it becomes a binary search tree? Here 1 is the answer, B is the answer. So there is only one way. The minimum value has to go to the leftmost node. That means set of n distinct elements ఇచ్చారనుకోండి. సో అప్పుడు మనకి ఎన్ని టైప్ ఆఫ్ బైనరీ సెర్చ్ ట్రీస్ డ్రా చేయొచ్చు అంటే ఓన్లీ వన్ binary search tree, because the leftmost, that means in how many ways can populate the tree with given set so that it becomes a binary search tree. Only one way, that is there is only one way. The minimum value has to be the leftmost node and the maximum value has to be rightmost the node. So recursively we can define for other nodes. Okay, how many distinct binary search trees can be created out of 4 distinct keys? 14. How it is possible? Now see here, this is the formula, that is I minus 1. The formula is like this. Now here, see the explanation for this. Here a systematic way to enumerate the binary search trees. Consider all binary search trees with each element at the root. If there are n nodes, then for each choice of the root node there are n minus 1 non-root nodes are there, isn't it? Okay, and these non-root nodes must be partitioned into, choose that there are less than the chosen root node and those that are greater than the chosen root. So let us say that I is the chosen to be root, then I minus 1 nodes smaller than I, n minus 1 I nodes bigger than I, isn't it? అంటే ఫర్ ఎగ్జాంపుల్ 5 రూట్ నోడ్ తీసుకున్నాం అనుకోండి. సో లెఫ్ట్ సైడ్ ఎన్ని ఉండొచ్చు అండి? మ్యాక్సిమం 4 లెఫ్ట్ సైడ్. దట్ మీన్స్ I minus 1 మీన్స్ 5 minus 1, నథింగ్ బట్ 4 నోడ్స్ ఉంటాయి. అదే ఇటువైపు ఎన్ని ఉండొచ్చు? n minus 1, దట్ మీన్స్ అదర్ దాన్ 5 అండ్ గ్రేటర్ దాన్ 5, దట్ మీన్స్ అండ్ n minus 1 నోడ్స్ బిగ్గర్ దాన్ I. ఓకే, అంటే 5 కంటే ఎక్కువగా ఉన్న ఎన్ని నోడ్స్ అయినా కూడా మనకి రైట్ సైడే ఫామ్ చేస్తాం. సో ఫర్ ఈచ్ ఆఫ్ దీస్ 2 sets నోడ్స్ దెర్ ఇస్ ఎ సర్టెన్ నెంబర్ ఆఫ్ పాసిబుల్ సబ్ ట్రీస్. అంటే ఏమవుతుంది మనకి మళ్ళీ ఈ 4 నోడ్స్కి ఎన్ని పాసిబుల్ సబ్ ట్రీస్ ఉంటాయి? 4 నోడ్స్ ఉన్నాయనుకోండి, పాసిబుల్ సబ్ నోడ్స్ ఫైండ్ అవుట్ చేయాలి. అలాగే n minus iకి పాసిబుల్ సబ్ నోడ్స్. లెట్ Tn బి ద టోటల్ నెంబర్ ఆఫ్ బైనరీ సెర్చ్ ట్రీస్ విత్ n నోడ్స్. ద టోటల్ నెంబర్ ఆఫ్ బైనరీ సెర్చ్ ట్రీస్ విత్ I ఎట్ రూట్ నోడ్, దట్ ఈస్ I minus 1. ఒకటి మైనస్ చేస్తాం, I minus 1 ఇంటూ Tn minus I. అంటే సపోజ్ 5 నోడ్స్ ఉన్నాయనుకోండి, ఓకే 4 నోడ్స్కి ఎన్ని సబ్ ట్రీస్ ఉంటాయి, దాంతో నేను ఒకదాన్ని ఇంటూ చేస్తాం. ఓకే, ద 2 terms are multiplied together because the arrangement in left and right side, so that these are independents. That is, for each arrangement in the left tree and for each arrangement in the right tree you get ith root node. So now summing over this, అంటే left side to right side to summing over this, summing over I gives the total number of binary search trees are n nodes. సో ఇక్కడ మనకి ఏం అడిగాడు క్వశ్చన్లో? హియర్ హౌ మెనీ నెంబర్ ఆఫ్ డిస్టింక్ట్ బైనరీ ట్రీస్ విత్ 4 డిస్టింక్ట్ కీస్ ఉన్నాయనుకోండి, మనకి ఎన్ని చేయొచ్చు అంటే 14 అంటున్నాడు. దట్ మీన్స్ 14 ఇన్ ద సెన్స్ హియర్ లెఫ్ట్ సైడ్ 2 and right side 2. For that ఒకసారి మీకు ఇది సాల్వ్ చేసి చూపిస్తానమ్మా. 14 తీసుకొని ఫార్ములా వేసి సాల్వ్ చేసి చూపిస్తాను. సో నెక్స్ట్ వీ కెన్ మూవ్ టు దిస్ KRA tree. So this is not completed for us. Now we can move to this. Which of the following traversal outputs the data in sorted order? We know that very well. That is a in-order traversal, because the left in the in-order traversal left root right. so that we can display first leftmost element. So that leftmost element is the smallest element, so that in the in-order traversal list elements are placed in sorted order. Next, suppose the numbers 751836092 are inserted in that order into an initially empty binary search tree. The binary tree uses the usual ordering on natural numbers. What is the in-order traversal sequence of this resultant tree? So, suppose whenever the questions are like this in order traversal, so just you can place all these elements in sorted order. Can place all these elements are in sorted order. Suppose they can ask the question in question like pre-order traversal. So in that case, you can first draw the binary search tree, and after that you can form the pre-order traversal. So whereas coming to the in-order traversal, no need to draw the binary search tree, because in the in-order traversal all nodes are in ascending order only. That means the nodes are displayed in the ascending order. We know that is because the leftmost element is the smallest one, so that in the in-order traversal compulsory the elements are posted in sorted order only. So that's why directly you can apply that logic and you can display that is. So no need to draw the binary search tree, and after that you can form the in order. So if they can ask the post order or pre order, then you can draw the diagram for this binary search tree, and after that you can post those values. They can ask if it is a pre order or post order. Okay. And coming to the next, the following number of inserted numbers are inserted in an empty binary search tree, that is 10, 1, 3, 5, 15, 12, 16. What is the highest, what is the height of the binary search tree? That is, here this is a 10 is the root node. First construct this root node. 10 is the root node and 1 is the smallest, comes to left side, and 3 is the highest to this one but smallest to this 10. That means this comes under left subtree, but that is right to this one, so that right. And coming to the 5, so 5 is the smallest greatest to this 3 but smallest to this 10, again come to right side of this 3. Now coming to the 15, so this 15 is the greatest to this 10, now comes to left side, and 12 is the greatest to this 15 but smallest to this 12, so that comes to left to this 15. Now 16 is the greatest to this 10 as well as 15, so that it comes to the right side for this 15. This is the binary search tree. Now the here ask the binary search tree. What is the height? So height is nothing but maximum number of edges from the leaf to node, root node. That means how many number of edges here? This is the leaf node 1, 2, 3. Here this is also leaf node 1, 2. Here this is also leaf node 1, 2. So maximum means this is 3. Maximum height means what? 3. So that height of this one is what? Only 3. That is answer is 3. Now coming to the pre-order traversal for this binary sequence, first draw the diagram. That means 30 is the root node, 20 left side, and 10 is left to this 10, and 15 is also right to 10, and 25 is what? Right to 25 is what? Right to this. That means first you can draw this. Here 30, 20, 10, 25, 15, 23, 39, 35, 42. That means for given elements, this is the constructed tree. So from this tree they can ask the question what? Post order traversal. That means post order means what? First means left children, left right. That means 15, 23, 10, 25. See here 15, 10, 23, 25, 20, next 35, 42, 39, 30. So this is what? Answer for this constructed binary tree in posted order. Next 24. So which of the following traversal is sufficient to construct the BST from the traversals? That is in order, pre-order and post-order. And to construct the binary search tree, which of the traversals which of the following traversals is sufficient to construct the BST? That means in any one of the given 3 traversals is sufficient. That means suppose pre-order or post-order along with the suppose they can either 2 or 3 is sufficient. 2 or 3, because in order traversal we know that means ascending order. That means whatever the pre-order element is given, first you can arrange those elements in ascending order, that means in order. So that in order is there, p order is there, then you can construct. As well as suppose they can give the elements in post order, so you can arrange those elements in order. So here we have in order as well as post order, then you can form what is that binary search tree. So that while forming the binary search tree, it is enough either pre-order or post-order. Automatically we can form the binary search tree. So this is about the different questions came from trees. So tomorrow we will discuss about some questions on graph concept, and after that we can discuss some more concepts in graphs.